Hi guys, hello everyone. This is Palak Jan. On behalf of Innovation and Entrepreneurship Cell NIT Raipur, I welcome you all to the day 4 of iTalk series on data analytics using Python. So without any further delay, let's start with the session. So you can proceed further.
Okay, thank you, Balak. Good evening to all. And this is the fourth day. We have already covered all the Python basics, Python sequences, Python functions, modules, and how to import and use modules. And then we have already started looking into the Python data analytics and in general, say, I would say data science specific modules we have started, and the first one, which would deal with numbers, is NumPy, which we covered in the overview yesterday. So today we will move forward, and we are going to see more tools. I will share my screen for the PPT. Just wait a minute. Hold on for a minute. Okay, fine. So is my screen visible?
Yes,
Yes.
sir, it's visible.
Okay, thank you. Yeah, so today is the fourth day, and as I said, we're going to see a few more tools which are related to data analytics and its required functionality. Today, we're going to see a few things. In fact, I'm trying to squeeze in almost three things today. First is we have to look at Python handling of files. So in short, we will have a look at how the Python handles files. At the moment, mainly I will restrict to only text files because Python can handle text files, binary files, and also it has got a lot of features as far as what we typically call file IO is concerned. So we'll be just again taking a quick look at how the files are handled in Python and how we are able to access the files in Python. Why it is required? Because whenever we are doing data science analytics, I said this twice or thrice previously that the data is available in databases many times, or the streams which are received from machines such as sensors, or it can be directly from files such maybe as Excel, where the data is entered by humans, maybe something like a survey data. So, whether it is coming from humans, whether it is coming from machines, whether it is coming from databases, the data is received in some file format, and obviously therefore the file which are there should be able to be accessed and handled by Python. That is the reason why we will look into files first, because immediately upon handling it in pandas, we are going to see that we are going to access like say CSV file. We already said that majority of the data interchange is standardized to be either in comma separated value, that is CSV files, or the JSON objects which can be interchanged. And that was the exact reason why we also saw certain features of Python, including maybe the last one which we took was dictionary. Okay, so let's start right away on this. And I have already shared the screen. I will stop my cam so that bandwidth will be properly handled. Now we will start with the presentation, but today it will be very less of presentation, although there is a presentation for the details, but many places I have just included pieces of code there in the presentation.
Hello, sir. Sorry for the interruption. Probably there is a network issue. We'll be continuing in a minute. Few more minutes, we'll be continuing the session.
Sir, you left around 5 minutes back.
Hello, sir.
Yeah, so we'll start.
Yes, sir. Sorry for the
I
interruption.
had
There
come
was a
up.
network issue.
Yeah, network issue. I know. We will start. Okay, so I was explaining about the files. I will start sharing the screen simultaneously. Just quickly run through what I talked in last 3-4 minutes when the network could not connect over to you. So what we are having here is files. That is what we are going to see. Subsequent to which we will be seeing the two important tools of data science and analytics. One is Pandas, which is a baseline tool. It is nothing but the two-dimensional graphs and everything that we happen to do on databases. Will also be seen to be done in memory, and in memory the processing is carried out, so it becomes very important from the point of view of pre-processing. Pandas, you will see as we move tomorrow to the real world example, and we see the techniques, statistical techniques in scikit learn, we will observe that it becomes very evident that we are actually working on a pandas objects. The second tool is Matplotlib, which is a data visualization tool. It's very important because it makes you visualize data in graphical form. It also allows the data to be seen from within the program, uh, either a screen or a GUI or a web page where you can embed that data visualization. And of course, you can dynamically change the contents or values or the forms of the graphs, etc. So all these things are making tools, data visualization tools such as Matplotlib and others like say Orange, very important. So today's work chartered is again pretty heavy, and we will be having files followed by these two. So Matplotlib and then pandas. So let's have a look at it immediately. I have got a presentation, but today's presentation, and of course some presentations tomorrow as well, they are just containing some important pieces of code, and therefore I will not be much moving to the presentation. Rather, we will see the code more, and of course, because now the code is becoming slightly bigger in size, I have made it prepared into a form, and I will show you the code, explain you the code. We will execute the code, have a look at it, have look at the results, and then I will share that code with you people. As I said, that all the data and code and presentations, everything together will be there available to you in a zip. Okay, so let's move on and start first of all with files. So we will move on to files, and files are very important. We have already said. Okay, so there is presentation, but rather we will straight away go to our editor. This is just what you can say a little bit of a theoretical part on the basis of files, which I have included. So we already know what files are and why files are, etc. So we will straight away see how we open and close files, open, use, and close files in Python. Straight, we will move on to that. Okay, so files or file IO is there built in Python. You don't need to import anything for us for a basic standard files. That is files which are text files where the data is stored as ASCII or UTF, that is Universal Text Format characters. So if that is getting stored in that form, you don't have to have any module or any package imported, a library imported. Similarly, if the files are binary files where the data is stored as bytes, pure bytes, numbers between 0 to 255, then also you don't need it. But if there are any specialized files you want to handle, like say you want to handle only Excel files, or you want to handle only Word files, typical Word files, you want to handle PDF files, then PyPDF, PyExcel, PyWord, these kind of modules will be required to be imported for managing and manipulating information which is stored in such type of files. Okay, so let's move on. As in this session, I am going to concentrate only on text files because CSV files are essentially text files, and even the JSON objects are heart to heart or fundamentally a streamed text only, and therefore we will be dealing with text files as far as the data is concerned, which will be required to be imported and taken into maybe a pandas object like data frame, and then we need to do a pre-processing and also some analytical processing on those things, on those files.
Hello, sir. Sir, you're not audible. Hello. Sorry for the interruption. Probably there's a network issue again. We'll be back in a minute. Hello.
No, seems to be repeated problem of network. Let's try to start again very quickly.
Yes, sir. Yes, sir.
Is my screen shared visible now? Yeah.
Yes, sir.
Okay, stop my cam and seems to be some real network issue problem. Okay, fine. So, going back 2 minutes quickly, file can be opened and file name can be given, like say I have given abc.txt since I am handling text files. As I was saying, we will be today only taking the overview of text files management or manipulations, because essentially the data files are text files. Both the CSV and JSON format are essentially files in text. Text files are those files in which the files are stored in terms of ASCII characters, or what we nowadays called as UTF, Universal Text Format characters. And those files can be opened by open statement in Python. And after that, we can have a mode specified. The mode specified here, it can be read, write, append, and the file types for the mode can be binary and text by default. So for binary files and for text files, you don't need any additional import modules. But if you want to handle specifically Word, Excel, or any similar type of files, or say PDF files, Then there are specific modules like PyPDF, PyExcel, uh, uh, which are available for use as libraries, which will be required to be imported. So here we are in short opening abc.txt file as for writing a new file and a text mode file. Okay, so this will open abc.txt as a file for writing, and it is open as a text file. If I want to write to this file, the function now, because f is an object handler or file handler as we say, so the file handle is now available in the form of f. Now f is available to me as an object to access the file which just I have created, and f.write will write to the file. Okay, so what I will write? I will write, say, something like just hello into the file. Okay, the out says 6. 6 means 6 characters are written to the file. Okay, now I will close the file. Simply close. Closing the file is very important and necessary every time you open a file. Before you are done with the program, you should be closing the file. In fact, the good rule is that as soon as the file requirement is done, or as soon as the necessity to have the file open is done, you should be closing the file so that the file doesn't get corrupted and it remains safely on your media disks. So f.close. Then I can open the same file abc.txt now for reading, because now it is available. Where it is available? Okay, obviously at the moment I have not given any path. So the file is currently available since I am operating in this NIT Raipur folder. The file would be available in this particular folder, and it will be there in this particular folder. So where I created a file. Okay, but anyway, you can see that. Just a minute. Where is the file opened? It is opened in called as I don't know, VAC 1939. It appears it is gone. Yes, you will see that the file has gone here. You can see that it has been created on 10th Feb 2022 1751, which is just now. And if I open the file, obviously it will open with a notepad as it's a text file, and you will see that it is just containing hello, which I had just written. Okay, so the file is very much there, and it is having whatever I have written. The information, the data is stored in the file. It's stored in the file. Okay. So if I open it now for reading, I will be able to open it. And if I open it for reading, now if I want to read, I will be doing f.read. But obviously, because now I am reading, it is going to return me the contents of the file, and therefore I must hold it somewhere. So I will hold it. It's a text file, so what I'm going to get is a string, and I will be holding it into a variable file buffer, suppose. So it is file buffer, and if I say what is file buffer, so file buffer is containing hello, which is the data that I wrote into the file. Okay, so in this way, the text files can be opened, used, closed. But anyway, this is not just the, what you can say, that doesn't finish the file IO. In fact, it begins the file IO. Okay, I think periodically today I will ask one of the coordinators that, okay, I am still on air or not. So just please tell me. It's
Yes, sir. Yes, sir. You're
okay, good. So yeah, periodically I will ask because a lot of network issues are being observed by us. Anyway, so thanks. Now, this is not, as I say, that's all for the file IO, but it is just the beginning of the file IO. We will not be able to cover all the aspects, but definitely some aspects will be needed to be shown. So, what is that? Like, say, what probably I can write is I will write the file once more, and this time I will write few lines into the file. So I will say that I will open the file. For now, the thing keep in mind, I have not closed it, so I need to close the file again. And after closing the file, I will open it again uh, for writing. Now, obviously, it will overwrite. Okay, so if I do this, it is going to overwrite. I have not, due to short of timing, I have not shown you one of the features of error trapping in Python, which is called as try feature. So try catch feature, or which is try except feature, which is there, which allows me to catch the IO errors so that the program is not coming out, what you can say, ungracefully, and I am able to trap all the Python errors, show them to the user, or handle them, correct them if possible. If not possible, at least graciously close the program, telling the user that there is something wrong with the program that has occurred. So that feature, in due to shortage of time, I really couldn't take it. But here, what I'm trying to do is that there is a file existing abc.txt, and I am trying to open it for writing. It is going to overwrite the file. Okay, and in this case, because I'm not uh, doing a try except catching of the errors. Okay, so typically what is called as the entire chapter would be there for error handling in Python. So that I couldn't cover, but this is going to overwrite it. We can stop this by checking this particular feature. Okay, so in short, this is overwritten. The abc.txt is absolutely blank now again. Okay, very quickly, I will write a few lines into that. So I will say this is first line. Of course, if I want to go to second line, I have to give \n, which will take me on the second line. Then f dot write. This is second line slash \n will write the second line, and then I will say one more, that is this is third line, it has written it. Okay, and if I say f dot close, it will close the file. Now if I open it for reading, it will open the file for reading. Now if I decide to read it into a buffer, obviously it is going to read for me by f dot read, just like before. And now if I want to see what is the file buffer, obviously I am going to get all the three lines. Okay, so it will say this is first line \n, this is second line \n, etc. If I say print file buffer, obviously the \n will be converted into a new character, new line character, and therefore the first line will be printed on first line, second on second, and third on third. So that is how the reading writing will take place. Now, but this is not the only way in which the files can be read. There are various ways of reading the files. Okay, one is already seen, f.read. I can read it in some different way. Like if I can say f.read 10. Okay, if I say f.read 10, it will read only 10 characters. Oh yeah, yeah. Now this good. This is good. In fact, this has happened. Okay, if I said f.buff is equal to f.read 10 and it returned nothing. Now why this has happened? Because I have already done f.read, which has read the full of a file. The entire file has been read. So normally there is a pointer maintained inside the file buffer, or pointer maintained inside a file handler, which has already moved to end of file. Okay, since I read the entire file, the pointer has already been moved to the end of file. So how can I go back to the beginning of file? So typically these two points in file buffer or file handle, they are called as BOF and EOF, beginning of file and end of file. So because f.read has been completed just now, the pointer is already at EOF. I need to send it back to BOF. One simple way, without much knowledge, is to just do a f.close and reopen the file. Whenever you open a file with a handle, the always the pointer is at the beginning. Okay, so if I want to do that, I will do that. I will do f.close and I will reopen it for reading. And now I will execute that 10 wala statement. So when I do that, when I see fbuff, you will see that only first 10 characters have been read. So it is not necessary that a whole of a file buffer be read. We can just selectively read a few bytes only from the file which is allowed. Okay, only first 10 characters are read. Obviously, the character pointer which is there inside a text file is also starting from 0 and going in n minus 1. Now, why it is so? Because obviously it is treating the whole of a file buffer as sequence of character. So the behavior is very similar to string, and therefore you will see that functions like len operate on file buffer. Now, file buffer contained 21 character first line, 22 character second line, 21 character third line. So it gave me a total length of file buffer 64. But if I take that of a fbuff, it will be only 10 because in fbuff I have read only 10 characters. Okay. Where is the pointer now? It is at 10. Why? Because characters from 0 to 9 in the file handle or in the file memory has already been read. So currently pointer is that position 10. So what will happen if I say again f dot read 10? Now obviously the f buffer will be next 10 characters. So it was, this is fi. Now it is starting from rst space line
Sir, you're not audible, sir. There's a network issue again. We'll be continuing the session. Just few more minutes.
Hello.
Yes, sir.
I think things are pretty bad today.
Yes.
It was interruptions. Now, can you tell me up to what point I had done?
Sir, actually, there was a voice lag from my side. Probably my network was not also working fine at that time, so I haven't.
Okay, fine. So, okay, I will see whatever is on the screen. I will repeat that. Fine. So, reading from the file can be done by f dot read. Without argument, it reads the full file buffer. With argument, it reads only those many number of characters from the current pointer position. Okay, the pointer can be moved forward and backward within the file buffer by seek method. So f.seek method allows me to move the pointer. So here the pointer has been moved to the beginning of the file. The file length will be given by len, and as you see the file buffer, actually I read the full file. It is giving me 21 characters, 22 characters, 21 characters, total 64 characters in the entire file. On the other hand, fbuff read only 10 characters, so len is given by 10. So essentially, file buffer is nothing but a sequence of character, and its behavior is almost similar to that of a string. The indexes are from 0 to n minus 1, where n is the total size of file in number of bytes. Okay, I can seek anywhere in the file. Okay, so if I say, if I am seeking to, you must be knowing 21 was the first line. So at actual position 21, because 21 will be 0 to 20. So if I go to 21 and if I do f dot read another 22, actually I am reading from slash n second line. Okay, so uh, I can move anywhere my pointer within the file without any problem. Okay, one more thing about this is that because this is a text file and you can have slash n in it, so you can also read the file line by line. So I can say now I will again move the pointer to the beginning of the file, say f.seek 0, and now I will say f.read line. Okay, if I say f.read line, it will start from the current pointer position and it will read up to that end of that particular line. Okay, so you will see that it has read, this is first line backslash n. Okay, if I do again, now the where is the pointer? Pointer is at the beginning of the second line in this case. So it will, if I do read line, it will read second line, and if I do read line again, it will read third line. If I bring the pointer back to the beginning of the pointer, there is one more way of reading the whole lines altogether by saying f dot read lines. Okay, so what read lines will do? It will read all the lines. So you will see that it is reading all the lines into a list. Okay, it is reading all the lines into a list. So this is first line, this is second line, this is third line. It has come as three elements in a list. So it is a list of lines which is come there. Because it is a list of lines, I can use it in for loop. Okay, so I can say for line in. Okay, I have not read it anywhere. So I have to go back to the beginning of the pointer and I have to read lines, but I have to read lines to say some variable. I will do say for lines, and then I can write obviously for line in lines. Okay, what is the meaning of that? For a variable line in list of lines which is already given name lines, what I can do, I can say print line. Okay, so it will print first line, second line, third line, but you will visualize that there is an extra line in between. Why it has become? Because from one print to another print, anyway we go to next line. But since there was /n character, we went to next line. So effectively there was one line gap in between. So if I want to avoid that and have the lines purely printed, the end operator can be used with a space or a null, and we can still run it and it will come on the same line. Because it's a space, it will come on the line, but one character shifted. If you use a null, it will come, sorry, it will come like this. Okay, so for line in lines, okay, it looks very English like. So for every line in lines, print that line. That is what is the meaning of this for loop. So these things are possible with the text files. Lastly, I will conclude this files part. Actually, this was supposed to be over in 30 minutes, but because of network interruptions, we are already overshooting by 7-8 minutes. Okay, no problem. We will close with a mode which is called as the append mode. Okay, so we have already seen read mode, we have already seen write mode. Now we will see append mode. Okay, so what is the append mode is, I have already closed the file. So now I will open it in append mode. Okay, the text file abc.txt is a text file opened in append mode. What is the difference between a read mode and append mode is that we are able to append to this file. But say you can say that you can also do a write, but you have seen that when you open a file for writing, it overwrites even if the file is existing. So now in append mode, if I open a file, it opens the file for writing, but the pointer is not at BOF, it is at EOF. So whatever is already there, now additional information I can put to the existing file. So now if I say f.write, one more line is added. If I say one more line is added, it will add that line. And obviously if I close it and open it again for reading and open it again for reading and do FB as f.read, I will read it in full. Okay, and if I say FB, you will see that this is first line, this is second line, this is third line, and one more line is added. So what is the difference between a normal write mode and append mode is that, first and foremost, whenever you use a file name in write mode, unless you are having a error handling in your Python, so you are using a try catch situations, you are trying to catch try except mechanism. If you are trying to do a write on a file which is already existing, it will simply overwrite it. But if you use it in append mode, it will not overwrite. It will allow you to write at the end. So technically the difference is that the pointer is not at the BOF, it is at the EOF. Okay. There is one more mode which I will not now go into details as the time will be really running out for us. So that mode is called as R plus mode. So what is R plus mode is essentially a read write mode. So in that mode, I can use f.seek, f.read, f.write. Okay, and f.seek can take my pointer anywhere in the file. F.read will read number of characters from that pointer onwards. F.write will write the characters from that point onwards. Okay, so you will see that 4 lines have been added. It is there. And we are having suppose I do a f dot close. I will do f dot close. Okay, just give me a feed. I'm on the air.
Yes, sir.
Okay, thank you. So if I open the file R plus mode, then I can write anything. So if I say f dot seek and if I say what was that, 21 character was there, no? So if I move on to 23 character, 23 character, and if I say f dot write, let's try. I don't know, it might be shifted by 1. I am saying f dot write is equal to that. I am again going back and seeking at 0, and I am doing a full read into FB, f dot read, full read into FB, and I am saying print FB. Okay, I shifted by, I should have said 22, not 23. So you will see that this is first line. Actually, that is second line was I was trying to do. But anyway, one T has remained. So I think 21 characters was there the first line. Yeah, so I should have written 22. Skipping 22 characters and coming to the 23rd character, it should be writing the index to be 22. That line is second line. So I have changed certain characters in between there. Okay, I have changed certain characters in between there. Okay, we'll try to do again once very quickly, and I will say f dot seek 22, and now I will try to do a write. Now it should be that space. I have written that. I will again seek to 0. I will do a FB read, and now I will print that FB read. Okay, so you will see that this is first line, that is second line. So this has been replaced with that. Fine. So I can do in short any changes or manipulations to the file. So totally, we have seen in files only text files, not binary files, for the want of time. And anyway, binary files are not really required because the data files are usually text files for science and data analytics. So we have seen 4 possible modes: read mode, write mode, append mode, and R plus mode. Okay, so read mode opens a file for reading. The pointer is at BOF, beginning of file. Write, if existing, overrides the file. If not existing, creates a file, and in both cases there is nothing inside the file, and therefore there is no character, so BOF is at EOF, so the pointer is at BOF only. Then if it is append mode, if the file is existing, obviously the append mode will take you to the end of the file, the pointer will be at end of the file, and you can write from there onwards. And finally, you can open the file in R plus mode, in which it is a read write mode. In such mode, you can freely use f.seek to move around in the file, f.read to read certain number or full characters, to write certain number or full characters. You can use f.read and f.write respectively. Okay, in addition to that, reading can also be made possible by f.read line, where you are able to read line by line, and f.read lines, where you read all the lines in the file buffer into a list. Okay, so this is as far as the text files are concerned. Let's move very quickly now to our tools, and we will be looking into the two tools. So I will just for a while move into my presentation. So you can just have a look at the files, access mode files, everything I have written in there, opening and closing of the files, using with clause with the file. So these are all many things I really couldn't take today because time is really short. Otherwise, file is usually a single 2 hour session normally, where we take all the of things of binary files as well as text files. Okay, now we move on to the data visualization, that is Matplotlib. So data visualization tools are there, and there are many tools of which we are studying Matplotlib. As I told you, there are many others like Orange, Tableau, etc. So Matplotlib is a very good, simple data visualization tool in which it helps us to create fast graphs, charts, and plots. We are also having some visualization tools which are very specific, like Folium, which helps us in displaying maps, manipulating maps, and showing different contents on the maps. Then word cloud, etc. So many we had explained that day, but we are taking Matplotlib. Matplotlib is creating plots. We can create plots, line graphs, charts, scatter plots, or dot plots. We can also have one plot divided into multiple plots, that is called as subplots. We can also create multiple or many plots. And in addition to bar charts, we can also create histograms and pie charts. So it is a very rich tool. It allows us a lot of color combinations, lines, thicknesses, and many help features which can be provided on the graphs, charts, and plots. So, what are the data visualization basics? Very importantly, it is an important data science and analytics component, of course. We already seen this data flow, and the data visualization comes here. Actually, I have shown it in the final visualization, but it also comes in the exploratory visualization. So whenever we are doing a exploratory data analysis, so typically data scientists and analytics popularly call it as EDA, exploratory data analysis, which is just before you enter into modeling the data and starting performing some meaningful operations on it, which will lead to some trends or predictions or some insights and results. So for that, usually it is modeled, the data is modeled, and before that, the exploratory data analysis is carried out. Visualization is the important part of it. Visualization is also important part of final analysis because it delivers your result, what you want to say, what you want to tell as an analytic, as an analyst, what you want to tell. It delivers you faster than text or statistical tables. Okay, so that is the data visualization in it. Now, what a data visualization should be composing, or rather, what properties it should possess. So, very quickly, we already know that there are three things which are necessary. One is that the display of data should be in appropriate format. So, data should be accurate. The data should be, what you can say, a very good appearance it should have, and it should have good aesthetics. So normally accuracy, appearance, aesthetics, these are all things which come into picture for a good data visualization. Certain types of plots and graphs are good for certain types of results. When to use pie chart, when to use bar chart, when to use 3D charts, etc. When we should be using horizontal bars and when we should be using vertical bars. Okay, so all these things, there is some methodology behind that, and that is necessary. So which will put you in the right perspective or in right appearance. Okay, and of course whatever data you are showing, it should be accurate. I will go to one subplot where I will explain that how we can actually compromise the accuracy in visualization to convey wrong results. Okay, but we will have that scene. Okay, I cannot show that in too much details again, but we will have a look at it once at least, somewhere in the entire process. Then, uh, of course, the color combinations and the look is very important, where the aesthetics come into picture. So, finally, we should have a correct graphics chosen and provided. We should have a very accurate data displayed, conveying whatever we want to say in a proper manner. And then the appearance and aesthetics should be really good. It should be pleasant to the user, and it should make user feel good rather. Okay, so these are all things important for the data visualization. So with that, let's start with Matplotlib. Matplotlib is a Python tool for data visualization. Python tool for data visualization. Okay, just give me a feed. I'm on air still. Good.
Yes, sir.
Okay, good. Now it seems that the network has stabilized. So let's move on to see the Matplotlib as Python tool of data visualization. Okay, so let me introduce you to another way of Python environment, which is called as a notebook. Now, why I have chosen this? Because it allowed me to have some programs already written, and I can execute them after explaining them rather than writing line by line programs. Uh, some of the good visualizations will require programs which are slightly longer in size, and writing them here line by line will definitely consume a lot of my time. And also, as you know, as a human tendency, you tend to obviously make some small silly mistakes, sometimes typing mistakes, and the program doesn't run or gets interpreted or compiled first attempt. So there could be some small typos here and there. So overall, that is a lot, what you can say, a time-consuming process. So today, because these tools, as I said, are little bit now moving towards slightly higher end, so the programs tend to become longer, and that is why I'm going to use that tools. Okay, I have also got ready programs written down in the hands-on sessions on the previous courses, which I could have used. In fact, I will use that also. But mm, rather than that, I decided that okay, we will introduce ourselves to another Python environment tool, and with the help of that, we will have ourselves acquainted with that. So okay, this is of course Spider which I'm using. So anything like Spider, PyCharm, etc. we can use. But let's see a notebook style ID of Python, which is there, is called as the Jupyter notebook. It's called as the Jupyter notebook. Okay. So, what is a Jupyter notebook? It is a Python notebook. It is a notebook style ID where you can go on adding it as if you are writing in a notebook, one below the other. Okay. So, I have got now two notebooks. In fact, I have got a NumPy notebook also, which I didn't use yesterday because NumPy, most of the program lines were one or two lines, which could be very easily done into an environment. But the NumPy, and also for tomorrow the scikit. So I will be sharing 4 or 5 notebooks also with you, which is one is on NumPy, one is on Matplotlib, one is on a Jupyter notebook. Sorry, not Jupyter notebook. Sorry, one is on Pandas, one is on scikit, and one is on uh, a mini project, okay, which is the last 1 hour that we are going to see tomorrow. Okay, mini project is nothing but one real world small example. We cannot take with big databases, but okay, one real world, small but real world example where we will see start to finish flow and some results drawn in the end. Okay, so this is a Jupyter notebook. Now in Jupyter notebook there are cells, and in cells, like say there are Python cells. In just 2 minutes, I will introduce you. So this is how notebook looks, and you will see that it is very similar to your IPython interpreter only, but now it is available in the form of a cell. Okay, it is available in the form of a cell. Okay, what is the advantage that I will show you very quickly, but in 5 minutes only we will take a very short round on Jupyter and then move on with Matplotlib. Okay, so as compared to IDE environment or as compared to command prompt environment, this is slightly different. Okay, what I can do? Okay, it is very simple. I can write any Python program. I say b is equal to 5, b is equal to 6, and I will say print a plus b, print a minus b, and maybe I can store c as a square plus 2a plus 5, some equation, and I execute it. So you will see that it has executed 5 plus 6, 11, 5 minus 6, 1. Okay, there are some commands. Okay, so I will not go into individual details because we are not taking a Jupyter tutorial. But I have to press Shift Enter to execute the cell. So that is happened. C, I didn't ask for output, so C output has not come, but the C computation has already been done, which probably I can have another print here and I can execute it. So you will see that it is saying 40. So whatever is the A square, 25 plus 2a is 10 and 5, so total 40 it is showing. Okay, so this is the way I can just go on going down from top to bottom. Okay, so this is what in a notebook style, and I can store it, I can copy it as a PDF, I can do lot many things with that. But what is a good thing about it is that I can also use a markdown language here. So I can say that, okay, introduction to Python, say by Shrikant Velankar. Okay, introduction to Python by Shrikant Velankar. And instead of the cell being called as code, I will make it markdown and execute it. So now you will see that it is, and I can also write notes in the markdown space. So if handwritten, sorry, typewritten notes are to be there, they can. That is why it is called as a notebook, just like a classroom notebook. I can just go on mixing the text notes, even some graphs from Matplotlib, etc., as you will see later on, and the code windows, they can be put together. So this is the way. So I have created another markdown here just to indicate that that's all for this. So, okay, so proper start to finish arrangement can be done. So which mixes code cells and text cells, which is called as markdown cells. So this is what is the Jupyter notebook environment in Python. for Python rather, or Jupyter notebook for Python environment rather, and which can be very easily used. So okay, this is what is there. So I will save it. At the moment, I will save it untitled. Later on, I will change it, the name, and add it. Okay, so it is there. So let's now start the Matplotlib Jupyter notebook. I will also show you some couple of standalone programs. Okay, so this is fine. So is it visible? Because now there could be slight problem with the font size. Just
Yes,
give
sir,
me
it's
a feel
visible.
that it's
Visible,
visible.
sir.
No? Size is okay.
Yes, sir.
No? Especially the code windows, because others will be pretty big, but the code window is not that very big. It's okay.
But sir, it's visible. Yes, sir. Visible.
Yeah. Okay. So probably we can go slightly bigger. Now I think I have reached the extents. Okay. So fine. So this is my notebook. So I have written something blah 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 just to express that notes can be done. And the heading is Matplotlib is a Python 2D plotting library which produces publication quality figures in variety of hard copy formats, etc. Okay. So the previous run, I will just clean up. So I will say the output clear. So the any previous run on the notebook will be cleared. You can in fact store it with the output and also create a PDF or any notebook format output with this along with the outputs. Okay. So okay, fine. So let's see first. Obviously, if I want to use Matplotlib, I have to import Matplotlib because it is a data visualization library, which is an external module, and we have to run it. Any module, the version can be obtained by underscore underscore version property of that, because it cannot be done with a module which is not a class library. But if it is a class library, you can definitely do it. Generally the publishers will put it in their class constructor method, some version number. So you are having, okay, so I run it, execute.
Hello, sir. Sorry, there's a network issue once again. Sorry for the interruption. We'll continue the session soon.
या हेलो
Yes, sir.
या आज का बहुत ज़्यादा ही कॉम्प्लिकेशन हो रहा है. ठीक है. अप टू व्हाट पॉइंट आई हैड कम?
सर आप वो नोटबुक वाला बता रहे थे क्लियर करके.
हाँ, बट आई हैड स्टार्टेड विद मैटप्लॉटलिब नोटबुक.
यस सर, उसके बाद वॉइस लैग हो रहा था
नोटबुक
आपका.
मैंने दिखाया छोटा सा बना के, एंड उसके बाद मैं
हेलो.
मैटप्लॉटलिब का नोटबुक ओपन कर दिया था, राइट?
हाँ हाँ सर.
Okay, ठीक है. So this is the Matplotlib notebook. I have imported Matplotlib and printed its version, whatever 3.3.4. Uh, Matplotlib inline, it shows that Matplotlib outputs will be available here and here itself inline. They need not be in a separate box. Matplotlib is having an object called as pyplot, that is Python plot, which is a major object of Matplotlib, at the what is called as the application layer or the paint layer, which helps us generate or construct number of different types of plots, and it has been instantiated as PLT. Similarly, NumPy imported and instantiated as NP. Okay, so the Matplotlib's pyplot object now is available as PLT, and NumPy is now available as NP. We have already seen the linear space, that is line space, for generating x-axis linear space points, and I'm here doing that only. Yesterday only we have seen towards the end the linspace command, so or linspace method of NumPy. So np.linspace 0, 5, 11, the meaning is that starting point is 0, end point is 5, and total 11 samples will be generated equispaced or linearly spaced between these two intervals. So that is there. And then y I am writing down as a function of x, y is equal to x square. So if I just happen to see these samples, you will see that when I run this, you will see that it is showing print x as 0, 0.5, 1, 1.5, 2, 2.5, up to 5, and y is x square. So it is generating a square 0, 0.25, 1, 2.25, etc. These are the squares. So I have generated two linear space vectors, or rather x-axis linear space vector and a second degree curve on that on y-axis. So you are having a plot of y against x now can be generated on the basis of these sample points. Okay, so plt.figure. Now what is plt.figure is the plot figure that will be constructed. I can also specify size between this figure. Okay, so a size can be specified between this figure. I will take one standalone program. In that it will be pretty clear what is the meaning of that. But it is something like I am trying to draw a plot now, and for that plot I need a canvas, and that canvas will be created by plt.figure, and that canvas size can be determined. I can specify plt.figure into bracket another bracket which will specify a size something like 5, 10, 6, 10, 8, 12, etc., which is approximately those many inches when it is actually taken a 1:1 scale output on a paper. Okay, so that is plt.figure. So I will create an empty canvas. It shows in terms of pixels what will be the size of that canvas which is written in there. It is an object, so it has already returning a pointer for that. Okay, but the object itself will not be seen unless I make a show on that. Okay, then very simple plt.plot x comma y. Okay, there are some more arguments. We will see that later on. But plt.plot x comma y, what it will do? It will plot y against x. That's it. All the other parameters we have not added, so they will take their default values. They will take their default values, and then plt.show shows the canvas with a plot on it. Okay, so I created a canvas, I created a plot on it, and I am now making the plot to show up. Okay, I am making the plot to show up. Okay, so good. The plot is seen. Okay, you will see that since there were defaults, not much paraphernalia or frills are added to the plot, but it has definitely generated, it has auto scaled itself. Why it has auto scaled itself? Because we know that x is moving from 0 to 5, y has moved from 0 to 25. So you will see that y axis is from 0 to 25 and x axis is from 0 to 5 automatically. By default, it has chosen the graph to be of blue color, and of course, it is of course a section of a parabola, because essentially y equal to x square. So essentially, it is a parabola from origin, second degree curve. So we are having our first plot generated. Okay, our first plot generated. Okay, so now we go little bit more complex or add a few more things to it. As against as usual, we are taking the same line space as was there in previously. So 0 to 5, 11 samples, y is equal to x square we are plotting. Plt.figure opens the canvas. Plt.plot is now you will see that it is printing, but now I have added one more component or one more option to it. So I am choosing the color to be red. So x comma y comma color equal to red, okay, which can be chosen. Then I can have a label given to the x-axis which says x. Label can be given to the y-axis. It says y. I can give a title to the graph. It is saying square of x. Okay. So you are having so many different properties and methods which are available for that. And you will see that after creating a canvas and plotting, I am adding a label to the x-axis by x label. I am adding label to the y-axis by y label. I am adding title to the graph. I am adding a grid to the graph, so which will make exact movement of the variable more clear to us. Also, I can provide the extents of axis. Okay, I can create the extent of axis. So I am saying that let the axis be 0 to 5, 0 to 25. Means it will be tightly held graph. Okay, if you see this graph, it has auto scaled itself, but the extents are not 0 to 5, 0 to 25. Actually, the graph is starting slightly below 0 for both x and y axis, and it is finishing slightly above 25 and slightly above 5 for x and y axis. Okay, slightly above 5 for x axis and slightly above 25 for y axis. It is very pretty good visible here. Okay, so I am putting a tightly uh, clipped axis, so the view area will be strictly from 0 to 5 and 0 to 25, and then I will make a plt.show. So if I execute this plot to the basic plot which was there, now we have added x-axis label, y-axis label, the title of the graph, and grid to the graph, and I am able to specify the axis of the graph. So instead of auto scaling, I can do my specific scaling to the graph. Okay, let's run and see how it looks. It looks much better as compared to first one. The grid has been added. Okay, the grid has been added. You will see that now exactly I am able to see that the graph intersects 0, 0 because it is tightly from 0 to 5, 0 to 25. So no additional spaces are there in the ends because of the new axis. Also, the title has been given to x-axis as x. Title has been given to y-axis as y. Okay, so that is the way I can do a graph there. Okay, now there are few more things that we can do to it, but we will see it some modifications being done here. So I will just copy this whole thing, and before going to the next cell, I will insert one more cell. So we will do some inline work here itself, and I will use this copied this thing. Okay, so to have it slightly differently shown, I will say that can what all things that I can do. What all things that I can do is that I can have all these things with a mode, like I can say I'm saying R dash. Let's see whether it accepts in inline mode here or not. Yes, it accepts. Okay, so it is the same graph. Okay, but what I have said R dash. What is the meaning of this? R is color red and dash is line graph. If I say B dash, you will see that the graph will be generated in blue. Okay, if I say G dash, the graph will be generated in green. In R, if I say dash dash, okay, if I say dash dash mode, what will happen? Just see. Okay, now the graph will be generated with a dotted line instead of a continuous line. Okay, earlier the graph was getting generated with a continuous line. Now the graph is getting generated with a dotted line. Okay, so I can have a few uh, variations or modifications done to the graph with this. Okay, let's see whether it accepts line width command here or what. Yes, you will see that the graph has become thicker. I will move it again back to dash, and I will say the line width to be 3. You will observe distinctly that it is much thicker line as compared to earlier. So there are so many properties. I'm just showing you a couple of them. So here I am able to adjust the line width as per whatever want changes I want. I can change the color. I can change it to be a continuous line, or I can change it to be a dotted line, and I can also, I think, change it to be a dash dot line. Let's see it accepts or not. Yes, it accepts. So you will see that it is a dash and a dot line. Okay, so R dash dot, R dash continuous line, R dash dot line, R dash dash dotted line, like that. Okay, so that is there. Not only that, I can also create a dot plot using this. So instead of this, I can say that I want Rx. So if I say Rx, what will happen is instead of line graph, now it will show points only, and each point will be X. So now you will see that what has happened, whatever 11 points that they were there, they have been plotted as a dot plot. Instead of a line graph, it has dot plotted it. Even in dot plotting, you can choose either cross or you can choose plus. So it will be made up of plus sign, or if I choose O, okay, if I choose O, it will be rounds. Okay, you will see that it will be coming in terms of dot. Okay, or I can also choose by putting a tilde, not tilde, caret. I can choose it to be triangles, or I can also choose it to be, I think, squares, capital S or small s. Let's see. Okay, small s. So I can choose it to be squares. So lots and lots of facilities are available here, and many commands are more are there. I can change the size of my marker. Marker means whatever are the dots here. I can have dotted line graphs, I can have continuous line graphs, I can have even multiple graphs. I'm going to show that. So, uh, like, for example, I can say that Z, okay, because I'm already having NP, I will slightly change this. I will say NP dot sine.
Hello, sir. You're not audible, sir.
हेलो.
Yes, sir.
गड़बड़ होने वाला है. एक्चुअली क्या होगा मालूम है, अभी ऑलमोस्ट पांडाज का कवरेज नील जीरो के आसपास है. फिर मतलब वो कल लेना पड़ेगा, तो एंड में बहुत ज्यादा कॉम्प्रेस करना पड़ेगा. मे बी टुमारो वी विल हैव स्लाइटली लॉन्गर सेशन. पहले इसको अनाउंस करके रखो. then
ठीक
only
है
will be
सर.
whatever is decided. Otherwise वो जितना हुआ उतना हो गया ऐसा हो जाएगा. अभी ऑलमोस्ट और मेरे को ये भी समझ में नहीं आ रहा है कि एग्जैक्टली कितना वापस पीछे जाना है. So what that makes is that almost 15 से 20 मिनट का अपना चला गया पीछे. Anyway, I will start immediately. ज़्यादा टाइम नहीं करते. Where was I then at that time?
सर आप पॉइंट्स ऑन ग्राफ बता रहे थे.
So I have
डॉट.
yeah, now I have just converted into a trigonometric space, but my axes were wrong. So I am now just changing the axis. So I am changing the axis x now to from 0 to 7 because I am moving between 2 pi. And this I will change from minus 1.1 to plus 1.1 because the values are going to move between minus 1 to 1. And obviously my line style should be now continuous line. So we will try to run with these parameters. Okay, and you will see that now I am actually getting a cosine wave, but the sine wave is missing because I have not done a z graph. So I will also add a z graph to it. So this line I will copy and I will put, instead of y, I will plot z. And now, of course, to distinguish, I will have a blue line. Let the line width be 3, no problem. In fact, two line widths look better with the functions. Okay, so we will be running this now to have both the graphs. Okay, so I am having a sine wave as well as a cos wave, and 7 is little bit beyond extents. So let's put it 6.3 because 6.28 is where the 2 pi is. Okay. So yes, so now you will see that now it makes the title to be wrong. So we will make trigonometric functions. Okay. So you will see that sine and cosine functions have been drawn there. Okay, so in this way, a lot of facilities are provided, and we have to just keep in mind that whatever we want to do to canvas should be done before the show. Okay, if you do something after the show, it may not be visible to you, especially inline. It will become very difficult to be visible there because a show will display the canvas. So changes ideally should not be done after the show. So labels add करना है, title add करना है, grid add करना है, everything you can do. Okay, so that is there. I can also actually have the grid to be adjusted. So I can have a grid to be adjusted as maybe say magenta and a dotted line. Let's see if it accepts. Yes, it has accepted it. So a grid is there, which is now available in a dashed line or whatever. So all these things can be carried out. A lot of functionality can be provided. I will just resort to a normal grid function for the time being. Okay, so you will see that I started off with a graph of a square, a single graph. I have ended with a sine and cos graph, two graphs in a single plot, and a lot of color combinations, width combinations, uh, dot graphs and line graphs both together, and different functionalities have been shown. Okay, now let's move ahead and try to see. Now you will see that we are trying to change a complete complexion by putting some transparency value like alpha, some new line style, width, a different type of a marker, and also the marker sizes can be blown up or blown down, and you will see that a graph starts looking completely different. You will see that there were some colors chosen and the markers chosen. Okay, although this combination might not be very good to eyes, in fact, this looks better according to me. But still, just to show you that different combinations as per the choice and liking can be created. Now here you will see that a line graph is also there, and uh, dotted dash dot line graph is there. In addition to that, the markers are also there. So points are also being marked. Okay, which is pretty very visible. Okay, I can do it in color equal to red, and whatever changes marker sizes थोड़ा छोटा करना है तो हम लोग छोटा भी कर सकते हैं, like that. Okay, so you will see that the markers are changed, everything is changed to red, and the markers which were too much gaudy according to me, there were too oversized, now I've been gone to correct size. Okay, moving ahead, let's see a subplotting, how a subplotting can be done. So there is a subplot command available for that. What a subplot does is a plot canvas is divided into number of subplots. So how many subplots you will have is shown with that triple argument 1 2 1. Okay, so what is the meaning of that? We will see that what is the meaning of subplot 1 2 1 and 1 2 2. We will see the graph first and we will automatically understand it. The first one is going to be a dashed line, red color, and the second one is going to be a dotted line with markers in green color. And of course, the functions are, first is x plotted against y. First is y plotted against x. Second one is x plotted against y. Okay, so obviously it is a reverse operation. So the parabola about what you can say mirrored about y-axis. In second case, it becomes a parabola mirrored about the x-axis because now y has become x. Okay, so these are the two graphs. So what has happened in one graph? We are having two graphs. Okay, subplotting, which is being done here. Now subplotting can be done and exploited further. So I will just try to have some more things added here. So I will say, okay, let's do it x cube, suppose, and say W. I'm putting W, and W will be something like, say, 2 into x, say, plus 3. Some functions I have put on the linspace. Okay, now my graph cannot be, obviously I'm trying to plot many functions. So I need to have more subplots within a plot. So what kind of more subplots I will have? One to one, what it indicates? The one to one indicates that I'm going to have a single horizontal split and two plots split vertically. Whereas I am currently plotting the first one of it. And नीचे वाला जो subplot है, it tells me that okay, I am in the same one, 1 to 2. I am plotting the second one. Now, obviously, I would like two more to be added. So I will add two more to this, and I will put one of them to be blue continuous line and one of them to be again red with a dash dot line. Okay. And this time it will be X against W, and in third case it will be X against Z. So there will be four subplots. But obviously I have to change the configuration. Now I will change two graphs vertically and two graphs horizontally. So it's 2 by 2. Okay, so 1 by 2 may first 2 by 2 and 2 by 2. So now obviously this is going to be a third position plot and this is going to be a fourth position plot. Okay, so I will have a 2 by 2 subplotting. So one graph will be divided into four subplots, and first subplot, second, third, and fourth will be like this. So we execute it, and you will see this is what we see. Okay, so first one is y against x, second one is x against y, third one is the x cube, and the last one is 2x plus 3, which is obviously a line. So there are four subplots which has been created into a single plot. Okay, so that is there. Suppose I y equal to x I don't like, so I am just removing it from the subplot list. Now I have got only three subplots. Instead of 2 by 2 combination, I can have 1 by 3 combination. So it is 1 3 1. This is 1 3 2, and this is 1 3 3. Okay, so a split will be there. Three graphs split vertically, horizontally, a single row. So single row, three columns. That is the way in which the graphs will be appearing. Okay, so you will see that now they are appearing in this particular manner. Okay, a square graph, a cube graph, and a line graph. Now you will see that first and second graph, they look very similar. So there is every chance that suppose my product is not moving against somebody else's product. I will try to put these two graphs like this. Okay, and showing that okay, my product is just good as somebody else's in my sales or in my internal presentation. Okay, so here I'm deviating from that data visualization principle of showing the accurate result in right perspective. Why? Because they look similar, but the scales are completely different. Okay, the other one is increasing at a cubical speed, whereas the first one is increasing at a square speed. Okay, so that is the way some manipulations you will find in many times in even newspaper graphs, especially political parties or even sometimes organizations. They will put such twisted graphs having some manipulation done to the scale many times. just to create a different kind of a visual picture. Okay, so I'm going to limit up to this only. So there are so many instances which are there and methods, but we will not talk about them as such. But subplotting is very much in. Can I do a 311? The answer to that is yes. So I can definitely do 311 because, say, in fact, for this, it is better way. It will look, in fact, better. 311, 312, and 313 will look better. Okay, and now the graph will look like three graphs, one below the other. Of course, at the moment, the canvas size I am not controlling, so they are compressed too much into a small one. But there is the way you can show different kind of subgraphs. Okay, so dual graphing is okay, not really much. Some weird pictures can be generated, but dual graphing again. Uh, Now, yes, one thing is added here. Most of the things are very similar. You are having a square and a cube, but what has been added is something called as a legend. So you will see that I am highlighting it, plt.legend. So what is a plt.legend? A label will be given to graph. So you will see that green graph is power of 3 and red graph is power of 2. And when you say legend, the legend will appear in a box. The box position will be automatically chosen so that it is not overlapping the graph. Okay, it can be anywhere on the graph and chosen not to be there in overlapping the actual plotted graph. Okay, so that is something very good because many times if you are plotting two or three different graphs, like say I will include at the moment because that is a little bit bigger program which I normally take for a hands-on. That is where annual production of copper, iron, and aluminium in India. It is shown with three different colors in a single graph with a proper legend, something like AL, FE, CU, etc. And some values taken from 2000 to 2020 in terms of million metric tons per annum, etc., MMTPA, etc. That is based on some small real-time data, so which I usually take. So there you will find that it becomes a really good-looking graph with a proper grid, with a proper legend, with a proper scale, with a proper title, and proper x and y axis labels. Okay, of course the Matplotlib program becomes something like 16, 17 lines. So this is one more in the line. Okay, I can generate a scatter plot. So you will see that a scatter plot can be generated by using a scatter command instead of plot command. So rather than plotting a graph, now I can generate a scatter graph or a scatter plot like this. So you will see that red and green scatter plots of size, different sizes can be generated, and it has been generated along with the legend. The series are visible to you, X and Y. These are the series which are
Sir, you're not audible.
you can generate uh, bar charts. So you will see that a bar chart has been generated, which is quite possible. In fact, I usually take that metal production example in which first the line charts are drawn and then later on bar charts are drawn, and then we put them side by side and we understand that bar charts are actually better depiction of comparative metal production of these because they give year by year how big is each bar. Okay, here of course it is a single bar chart, but you can have multiple bar charts in that. I will add those programs in the whatever that I am going to give in the zip. So they will be definitely be there. Okay. Then okay, this is simple. Okay, so this is as far as the Matplotlib is concerned, but actually Matplotlib is not really speaking over. Where is the histogram? Okay, there was a histogram. Yeah, the histogram is there. Thanks, उसके ऊपर चला गया है. Okay, so I can even generate a histogram with whatever frequencies and number of samples and population. So obviously, because I can generate histograms, I can also have the mode plots generated for population density, and then of course with some small numpy programming along with that, I can also generate the distributions, adding the formula like say Poisson's distribution, etc., or standard normal distributions can be also drawn on the basis of that. So deviation plots and distribution plots can also be generated on the basis of that, which is of course, as I said, we'll have some more programming because it will be involving some mathematical formulations, and in addition to that, the Matplotlib commands. Okay, I will now move on to a standalone program because I don't think I have sufficient time to even start pandas. It's hardly 15 minutes remaining. So I will go back to show you couple of standalone programs in Matplotlib. And why they are important or why they are good, because they are having those various additional operations shown in there. Okay, so let's open it. Okay, so first of all, you will see that the categorical plotting program, what I have tried to do is similar to what subplotting that we have seen, but just it gives you a proper comparison. So I'm running this. Okay, so you will see that I have generated a line graph, a bar chart, a dot plot, and a dotted line plot for the same data. Okay, purposely we have done it for the same data. So the first one is a bar chart, and you will see that how different kind of messages they may carry, or they will give you a different kind of picture. Some may be more appealing as compared to other ones. Okay, so you will see that the data is very same. It is between 2008 to 2018, and some values are there: 10, 30, 60, 70, 80. Okay, things are taken very simple, but the categorical plotting has been shown in 2 by 2 kind of subplotting scenario. Okay, so this is one of the program which is very important there. Now, whenever we want to see some other type of results, such as male population is to female population, or what are the what you can say, a percentage share of a particular party in election, and shares of different parties in election, or say if we want to see like say recently, if you see on a COVID, what is the percentage of male and female or first and second dose of vaccine, or what are the percentages of 0 to 18, 18 to 45, 45 to 60, 60 and above people. So you will see that it is really being done and this is one of the very good site. If some data analytics want to study, you can just go. It has been built very nicely, very fast, I would say, and gives a lot of information and analytics. It is one of a very good recent site which is there to look for uh, visualization. Okay, so I will run and you will see that, just see the way in which it has been put. Okay, it is showing some graphs for today up to now. From morning, 45 lakhs 91 512 vaccinations have been carried out of which how many are partially vaccinated, how many are fully vaccinated. There is a line graph continuously running on the downside. Till now, 171 crore shots have been taken. Out of that, 74 crore people have completed both the doses. 95 means additional 20 crore have done only one dose as on today. And 1.56 crores have been done with the precautionary doses, which has started just around 15 days back. Okay, so you will see that this is a marker plus line. So it's a line plus marker shot, which is there, and it shows you the today's progress of that. And if you move the cursor over, some additional statistics can also be provided. That okay, today 12 hours to 13 hours, total 10 lakh doses were administered, out of which some were dose 1, some were dose 2, some were precautionary dose. Coming down, you will see that multi-bar chart is there, vaccination by age, which shows that maximum doses have been given in, obviously, which is quite natural because it is the demography of the country as of now. So 18 to 44, the maximum doses have been used, and then 45 to 60. Then you are having on the right side a proper pie chart, and in the middle, it is what is called as the hollow pie chart or a donut chart, which is there, and it shows vaccination by gender. Again, you move over the cursor, it gives total 80 crore shots on female and 86 crore shots on male. Total 145 crore shots of Covishield, total 25 crore shots of Covaxin, and we have to be at little bit pains to arrive at Sputnik, some 15 or 16 lakh shots of Sputnik. Okay, and then it gives the what is called as the population density or distribution chart for all over India, and also a hollow bar charts for each of the states. And if you scroll down, you will get, like, say, you come to know that till now, maybe Uttar Pradesh will be maximum, more than 25 crore shots given. So, like that. So, Uttar Pradesh, 27.39 crore shots. Next will be Maharashtra, and it is almost 15.13 crores, and so on and so forth. So, of course, that is proportionate to the population of that particular state. And again, a bar chart, and you will see a multi-bar chart showing the rural against urban trends, and then some one more line chart showing that how many bad cases, means some bad effects after the shot was taken. That is typically called as AEFI. I don't know the long form. At the moment, I'm not remembering the medical long form. So this site of dashboard.covin, lots of graphics and lots of data visualization. In fact, in a single screen, it captures everything as far as the vaccination drive in India from last 16 January is concerned. Okay, so that is one thing. Coming back, the last one that I will take up on the program is one more standalone program. So obviously, you will see that we saw bar charts, we saw scatter plots, we saw dot plots, we saw line charts, etc. But whenever it comes, like, say, proportions, percentages, okay, kind of a scenario, the best chart to display is a pie chart or a donut chart, hollow pie chart, or what is called as the 3D pie charts are also available. in certain higher degree uh, packages. So in Python also they are available. On top of Matplotlib, you will require some additional packages, and you can do that also. So a 3D version is also available, which is built on top of Matplotlib. Matplotlib in itself doesn't give many or too many of the facilities as far as the 3D is concerned. Mm. Okay, so we will conclude with one last standalone program, which I will take. So here, of course, it is just a subplotting, but this program is a good example of pie chart. So pie chart, histogram also we saw in fact. So histogram automatically we can also do once the histogram comes. We can also do the frequency density or population density charts and distribution charts. So let's see now the uh, matplotlib program. Okay, so the matplotlib program, which is there, we will run it. But before running that, let me tell you what all things are there in this. Okay, so you will see that I have created labels which will be given to the slices of the pie. Okay, so this is a distribution of language popularity which is given for the four most popular languages in the world. Okay, the data is sample, not true, because if it had it been true, the Java would have been bigger. Java is the most used language, to which next is Python now, and of course there are sectors. So data analytics, data science, AI, ML, DL, certain sectors. Very big coming in image processing, because the MATLAB is proving too costly, as against that Python is open source and free. So OpenCV2, Pillow, and so many different libraries which are available there for image processing. And certain areas, Python is actually the top language. Web programming and many allied areas in two-tier and three-tier application programming, I think Java is supposed to be way ahead of others. And then for specific usages, Ruby Rails or Ruby on Rails or whatever Ruby language is being used, and many others are being used. So this actually distribution, I have taken it from net. Maybe the values and languages, maybe for a specific application this could be the distribution, but more so it is just for showing how the pie charts are drawn. Okay, sizes are their relative sizes, things come automatically. Colors that will be assigned to those slices. So in short, Python is having 215 population, which will be obviously generated by for a slice by its value, like say x1 upon sigma x, and for C++ it will be x2 upon sigma x, like that. And colors will be that Python will have gold, C++ will have yellow, green, and so on and so forth. Now, what is the meaning of explode is that the Python, I want to highlight how Python is very useful or very widely used. So, I am highlighting Python in this particular scenario, which is called as explode. Okay, now you will see that I have created a fixed size of 10 comma 10. Okay, I have created a fixed size of 10 comma 10. So you will see that, as I said, the canvas can have size. So here I have created a fixed size of 10 comma 10, which is approximately a print area of 10 inches by 10 inches when printed with a scale equal to 1. You can scale it up and down. Normally we do a fit whenever we print, so we say fit to the page. Okay, and then I say plt.py, just like plt.scatter, plt.plot, plt.hist. It is plt.py. So what I need to plot the sizes, explodes, name labels, and colors. That is what I will plot. Now, what is autopacity? Whether I want to show the percentage or not. And if I want to show the percentage, what should be the format of showing the percentage? It says that it should be 3 by 2. So 3 by 2 will be something like where you can go up to 100.00. Okay, which is, of course, for percentage, the most normal form. Whether I want a shadow effect, I am saying yes. What will be the start angle and what will be the font size? Okay, so all these things. uh, what do you mean by plot axis equal? Means it will be a circle. I can also generate an ellipse by unequal plot sizes. Okay, so let's see how it looks. Okay, so if I run this, you will see that it has created a pie chart. You will see that the percentage have come automatically. You will see that the percentage have come in 16.25 because it is a format identifier. I want to show percent, I have to put it twice. So I have put percentage, which is very easily visible. Then it says that all the languages, C++, Python, Ruby, Java, etc., and their relative percentages. You will see that the Python slice have been cut aside, exploded aside. That is to show that, okay, I am talking because how it is. So if there are, say, my market share is 40%, and then there are 4 or 5 players, I will obviously show my market share exploded as 40%. Okay, because it is from my point of view I am presenting. So that becomes quite important. Can you do slicing for 2? Yes, you can do slicing for 2. So I can say that I want to explode C++ point 1, but I want to explode more away Python with point 2. So which is there, and maybe I will say that, okay, I want the font size to be 22 instead of 24. एकदम बड़ा हो जाएगा. And I will run it again. So you will see that now the font are much bigger as compared to earlier. C has been sliced out slightly, but Python has been sliced out more. It may not be looking good here because they are adjacent. So normally multiple slice out are there. They will be shown not adjacent, but they will be shown uh, away from each other. So maybe I have to change the order. Okay, so I will just forget and put it 0, or just 0 is good. And this also, it has blown too much out of proportion. So I will run it. You will see that it is now again back to the normal, but the fonts 24 are looking better. Okay, what is the meaning of this? Is that I want round percentages. I can select 33.0, then only the round percentages can be taken. Also, start angle is 0 at the moment. So the first slice pie, which is Python, which is starting horizontally, I can say start angle is 90. The whole pie chart will be rotated 90 degrees. You will see that the Python rotation now, the first slice starts at 90 degrees, that is vertically up direction. And the percentages have come as a round figure because I have changed the values to 3.0. Okay. So there are various facilities which we can generate out of this using a pie chart in Matplotlib. Okay. So we will see that Matplotlib is a very rich library. You are having practically innumerable combinations in which the plots can be generated. You can generate a bar chart, you can generate a line plot, you can generate a scatter plot, you can generate a dot plot, you can generate a histogram and distributions, you can generate pie charts, and so on and so forth. And you can have various options and facilities in terms of colors, widths, effects, which can be given to these plots. You can also generate subplots in so many different combinations: 1 by 2, 2 by 2, 1 by 3, 3 by 1, 2 by 3, total 6 plots. 2 by 4, maybe in the 3 by 4. So of course those plots become smaller and smaller in size, or we need to increase the size of the canvas. So all these facilities are provided by Matplotlib, where we are able to plot the real-time data. So this is as far as the utility Matplotlib is concerned. We also saw files today, and we also saw how to use notebook-like IDE of Python, which is called as the Jupyter notebook. So all these things we covered. Ideally, I think I should have gone almost 2/3 way through pandas, but anyway, there were some unfortunate interruptions due to network. We will continue with pandas tomorrow. In the beginning, we will we will move ahead with scikit-learn, and we will then end up with one real-time analysis example tomorrow. So that will be tomorrow is my last day, where the charter will be, where I have moved you from basic Python syntax to a first step into some data analytics, or first step into some data science, where you are able to generate some result. The results might be something like known results, but I will be able to say that, okay, this is, if this is done, this will happen, or this is directly proportional to a good extent on these entities, etc. Okay, so some predictions or some trends or forecasts we will be able to make on the basis of that. Okay, so with that, I think fine. So Matplotlib, most of the things we have covered: the line graph examples, the subplot examples, the multi-chart examples, the pie chart and histogram examples, which are done, and that concludes the today's session from my side. Thank you very much to you all, and madam, I think we can close the session.
Yes, sir. Thank you so much, sir. So, with
Yeah.
this, we'll end our today's session. Thank you so much for everyone for joining us today. We'll see you tomorrow again. Thank you so much, sir.
Okay. Thank you.